Hi, and welcome back to our chemistry flipped classroom. And today we are continuing our discussion of the what a formula tells us and what we can learn from a formula and what ingredients or elements are in a compound. So our last lesson we learned about percent composition, and now we're going to learn about something called empirical formula. So empirical formula is a formula that's determined from empirical evidence. And that word empirical means that it's laboratory based. So what this means is that we have done some sort of a laboratory process, and we've discovered what the elements are that make up a compound, as well as what percent by mass each of these is in that compound. And so we're going to use that information to go backwards and determine the formula. So before we had the formula and we determined percent composition. Now we're going to take that percent composition and we're going to calculate the formula. So how are we going to do that? Well, the first thing that we're going to do is that we're going to assume, because percent is out of 100, we're just going to assume that we have 100 grams because that makes the math easy, and we're going to convert percentages to grams. So whatever percent we have, we now just change that from percent to grams. Now we're going to divide the mass of each element by its molar mass. So we're going to look at the periodic table. We're going to see that the mass of carbon is 12.01 as an example, or hydrogen is 1.01. And we're going to divide the mass that we just converted to grams by the molar mass. And then we're going to divide the number of moles of each element by the smallest number of moles, and I think that'll make more sense when we have an example. So we're going to have, depending on how many elements we have, we're going to have a different number of moles of each. We're going to pick the smallest one of those numbers, and we're going to divide by that number to find the ratio. And then if necessary, so if those numbers don't come out to be whole numbers, we're going to multiply by an integer to get whole numbers. So if one of those numbers, for example, was 1.5 or 2.33, then we would multiply, if it's a half, by 2, if it's a third, by 3, in order to get whole numbers. And if we multiply 1, we have to multiply all of them. And then finally, we're going to use those integers that we get from that result as the subscripts in our empirical formula. So let's take a look at an example, and we'll work through the process. So here's our example. We have this compound with this crazy name, para-aminobenzoic acid, which is frequently abbreviated PABA, and you might be familiar with that as an ingredient in your sunscreen. So para-aminobenzoic acid is composed of 61.31% carbon, 5.14% hydrogen, 10.21% nitrogen, and 23.33% oxygen. And we're being asked to find its empirical formula. So we're given percent composition, and we're asked to find empirical formula. So we're going to lay this out. So we have 61.31% carbon, 5.14% hydrogen, 10.21% nitrogen, and 23.33% oxygen. So we're going to assume that these are out of 100 grams. So we're just going to change all of these percents to grams. Okay, make our lives simple. If we have 100 grams, 10.21% of that is 10.21 grams. If we have 100 grams, 23.33% of that is 23.33 grams. So we can just change all of those percents to grams. And now we're going to divide by molar mass. So for carbon, I'm going to divide by 12.01. For hydrogen, I'm going to divide by 1.01. And you can use more decimal places if you want, pulling from your periodic table. But because these are going to be approximate numbers, I usually just stick with 2 decimal places. For nitrogen, then, we're going to divide by 14.01. And for oxygen, we're going to divide by 16.00. Okay, so when we do that, we get that we have 5.105 moles of carbon, we have 5.09 moles of hydrogen, we have 0.728 0.88 moles of nitrogen, and we have 1.456 moles of oxygen. So we have changed our percentages to grams. Now we've divided by molar mass. The next step is to divide by the smallest number. So the smallest number that we have here is this 0.7288. So we're going to divide all of these numbers by 0.7288 because what we're looking for is not an absolute number of moles, but a ratio of moles. So we want to know for every 1 mole of something, how many moles of everything else are there. So the easiest way to do that is divide by the smallest number. So we're going to divide everything by 0.7288. And it's pretty easy to see that this is going to give us 1, and this is going to give us like 2. Oops, I left out a number there, sorry. This is going to give us something like 2.001, and we're going to say that's close enough to 2. And this is going to give us 6.984, so we're going to say, well, that's really close to 7. And this is going to give us 7.005, and again, we're going to say that's really close to 7. And so now we have this 7, 7, 1, and 2. And so those now in our last step, because we don't have any fractions, these are all integers, I don't have to multiply by anything. So my last step is that this is C7, H7, N, now we don't have to put a subscript 1, O2. And that would be the empirical formula for paraminobenzoic acid. Okay, so we'll do one more example. We have ethylene glycol, and ethylene glycol contains 38.7% carbon, 9.7% hydrogen, and 51.6% oxygen. So again, I'm going to change these percents to grams. I'm going to assume I have 100 grams. So we've done step 1. Now we're going to divide by molar mass, 12.01 for carbon, 1.01 for hydrogen, 16.00 for oxygen. And that's going to give us 3.22 for carbon. It's going to give us 9.60 for hydrogen, and it's going to give us 3.22 for oxygen. And again, we're going to divide by the smallest number. We have the same smallest number twice, so we're going to divide by 3.22. And that's going to give us 1 and about 3 and 1. And so now, again, we have whole numbers, so I don't have to multiply by anything. And we have CH3O. And that's going to be our final answer for our empirical formula for ethylene glycol. As always, I look forward to hearing your questions and seeing you in class.